What's up? What's up? What's up? It's your boy, the network. And today's topic is Section 315, Configure and Verify Loop Prevention Mechanisms. This is subsection 3.15, C Charlie, route poisoning. This is the topic in the Cisco CCNP route exam code 300-101, version 2.0. Let's take a look at the exam blueprint to see where we came from and where we're headed. Hashtag labeveryday. All right, so this is the exam blueprint implementing Cisco IP routing. Again, this is also known as the CCNP route exam. We just wrapped up the section Split Horizon, which is a loop prevention mechanism. We are also going to do today another loop prevention mechanism. It's route poisoning. After that, we're going to move on to configuring and verifying, yes, RIP, version 2. That is an older routing protocol, but it is a requirement for this exam. So it is a routing protocol basic, and we need to cover that. But today we're going to be doing route poisoning. Okay, so what is route poisoning? Route poisoning is obviously a loop prevention mechanism, right? What is a routing loop? A routing loop is when a packet goes in the network and you configured it some way that is not very optimal, and it causes the route to loop into the network, right? And it never gets to its intended destination. Well, we have different ways to stop this from happening. Route poisoning is one of those ways. What does route poisoning? Simply put, route poisoning is when let's say you send a packet into the network, but the destination they were supposed to go to, the route went down, right? When that route goes down, a router that has that route will let other routers know, hey, this route went down. But instead of simply saying the route went down, it basically poisons the route. What does poisoning mean? Poisoning lets the other routers know, hey, this route is impossible to get there. The way it does that is it depends on the routing protocol, really. It basically says you got to take a space shuttle to get there, or you got to go to another dimension. And then the router that sees that, another router that sees that the route that you were trying to get to is impossible to get there, it'll just be like, oh, that's too long. Let me take this off my routing table. And then basically that poisons the route. I don't know if I really explained that right. So let's go ahead and take a look at the official definition in the slides. So route poisoning. Route poisoning occurs when a router learns that a route to a destination has failed. I did say that. For example, a RIP router, because different routing protocols determine a route as poisoned or unreachable in different ways. A RIP router will advertise the failed destination out of all of its interfaces with a metric of 16, which is considered unreachable, right? Because remember, the metric that RIP uses is hops, right? So and the maximum hop count for RIP is 15. So if a RIP route is more than 15 hops, then it'll say, oh, that's unreachable. That's too far. It's going to take it off its routing table. So that's what route poisoning does. If you have a RIP route that's more than 15 hops away, it's going to take it off its routing table and consider it too far. Well, OSPF and EIGRP does it in different ways. Anyways, this tells all of its neighbors it no longer has a route to that specific network. As you can see, if you look at this topology right here, we have the 10 network right here on the right-hand side, right? Let's say the 10 network goes down, right? This 10 network goes down. So router 2 would send him an update with a metric of 16 and say, hey, router 1, to get to the 10 network, it's 16 hops away. Router 1 is going to be like, oh, that's too far. RIP, if it's more than 15 hops away, then I need to take this off my routing table. And that's what essentially he does. And that's what route poisoning is. Now, EIGRP and OSPF handles it differently. EIGRP sends out an infinite metric. I'll show you what the number for the infinite metric is. We'll discuss the metrics of EIGRP once we break down EIGRP, the routing protocol, in the later objectives. So I'm just gonna tell you what the infinite metric is, and then we'll move on. And OSPF sends out an LSA. Same thing with OSPF. We're gonna have to start talking about OSPF as a routing protocol, and then we're to talk about LSAs, which is link state advertisements. Basically, it sends out a link state advertisement with an age of 3,600 seconds, and then once he sees that, he's like, wait a minute. This LSA is 3,600 seconds. I got to take this off my routing table. Same thing with EIGRP. When a router receives an update that says hey, the metric for this route is, I'll tell y'all the number. Actually, here's the number. This red number right here, it's for whatever. Basically, when it sees that in its when it receives that number in its update, like, oh, that's too far, and he's gonna take it off his routing table. Simply put, that right there is the calculation for EIGRP metric, right? That's the maximum metric value for an EIGRP route, 2 to the 32nd power minus 1, which is that number right there. Let's go ahead and spin up GNS3 and discover what happens when a route becomes unreachable with OSPF, EIGRP, and RIP. All right, let's take a look at this topology right here. We have 3 different routing protocols here. We got a RIP domain right here in the yellow. We have an EIGRP domain in the pink. And then we have OSPF split into 2 areas. We have area 0 in the blue, and we have area 1 in the red. We are going to shut down the network in here and see what happens when a network goes down or a route goes down. So let's go ahead and start off with the RIP domain, right? Let's take a look at router. Let's take a look at this network here in the RIP domain. We got the 1 network, which I believe is going to be on a loopback, right? Then we have the 2 network in here, the 3 network in here, and have routers 1, 2, and 3 in the RIP domain. Let's take a look at router 3 and see the RIP routes, right? Console in router 3 real quick. Show IP route, right? So he has all these RIP domains. I mean RIP routes. He got 1 to the 9 network, the 6, the 1, 2, and the 3, right? 9, 6 is all down here somewhere. It's all down there somewhere. Anyways, we have the 1 network, the 2 network, and the 3 network. Let's see what happens when we shut down the 1 network, which is over here, right? And we're gonna, and from the vantage point, see what happens with router 3. We're gonna have to capture its packets when we do this, though. Let's, as a matter of fact, let's go ahead and start that. Right, so right now we are capturing packets that are going between these 2 routers. Actually, some that's coming over here too, whatever, and comes across this network here. So let's go ahead and open up some of these packets, right? We have a couple RIP updates right here. Let's go ahead and take a look at one of these, right? The source is 3.2. That's actually, I believe, this guy. So we have a packet coming from here to there, right? Now you can see the metric to the 4 network is 1. That means 1 hop away. The 6 network is 2 hops away. 9 network is 2 hops away, right? We need to see something that's going to happen. Let's see, we got the 4 network and stuff too, right? Yeah, we got the 4 network over here. Let's do this instead. Yeah, we're going to shut down the 1 network and see what happens when this route becomes unreachable. Router 3 says to get to the router to the 1 network, it is 2 hops away. 2 hops this time. 2 hops this time. And then let's see what happens when we remove that route, right? Shut that guy down. Let's go ahead and console into him. Console into router 1. And I don't remember if that was a loopback or an interface. I believe it's a loopback, or if it's a physical interface. Show IP interface brief, exclude unassigned. And the 1 network is the fast Ethernet 00, right? So we got to shut down 1.1, which is an interface that's over here. We're gonna shut him down, right? And then let's take a look at our Wireshark capture when we do that. We're gonna shut down. So we're gonna configure, go into global config mode, interface FA 0/0. We're gonna shut that guy down. We are going to receive, okay, now it's shut down. We are going to receive some RIP updates. Right now, there it is. Yeah, there it was right there. So right now it says 172.16.1.0 network, which is this interface, which is this network right here. He says that the metric is 16. So he says, hey, it's 16 hops to get that way. And then router 3 eventually says, okay, you know what? I got to take that out of my route. Out of my routing table. So let's go ahead and take a look. Obviously, when you shut it down, let's go into router 3, show IP route. Remember, he had it in here, and it was 2 hops away. Show IP route, and now it's gone. It's no longer in his routing table. So we poisoned the route with a 16 metric, and he says, oh, that's too far, and he took it off his routing table, and that's essentially what happens. So that's what RIP, that's how RIP poisons routes. This is what route poisoning is. So now let's go ahead and take a look at EIGRP and see how EIGRP poisons routes. Let's go ahead and examine some EIGRP route poisoning. Let's go ahead and go over that again. RIP sends out a metric of 16 hops. EIGRP sends out an infinite metric, which is basically this number right here. It also sets, I believe, it changes the sequence number up by 1, and I'll show you that as well once you do a show IP, I believe, topology, but we'll see. So let's go ahead and do the same thing on this side, right? We're going to capture packets on this right here. Let's go ahead and console in the router 6. We're going to shut down the 55.0 network, which is somewhere over here, and see what happens with router 6. Actually, no, let's not do that. Let's do it with router. I'm going to stop this guy. Let's do it with router 4. Let's do it in between these two guys right here. Let's capture the packets in here. And go in the console in the router 4. Right? So we have the 55.0 network, and let's see what happens. Let's take a look at our routing table on router 4. Show IP route. Here's the 55.0 network. AD is 90. That is the metric, right? Via 16.5.5, which is this interface right here, right? What happens when we shut that down? Obviously, he's going to take it off his routing table. But what happens with the poisoning? We need to see the route poisoning happening, right? First of all, let's take a look at router 4's topology. Also, show IP, EIGRP, topology. Let's do all links. There's the 55.0 network. And there's the metric again, FD, feasible successor, right? Yeah, that was the metric, right? Now, basically, he's just gonna remove it, but we need to capture that because EIGRP is so fast, so we need to use it. We need to put our magnifying glass right here and see what happens. So let's go ahead and shut down the interface that's gonna be over here, which I believe on router 5. Let's go ahead and console on router 5. Which we are, and let's do a show IP interface brief and take a look at that. Okay, so it's FA00, 55.5. We need to shut that guy down and see what happens, right? I'm gonna bring up Wireshark and capture while this is happening, right? Let's go ahead and interface FA00, right? So we're going on that interface that's right there. We're gonna shut that bad boy down. Shut. And let's see, we've got a couple EIGRP updates right here. Okay, so this is what we was looking for right here. 5.5, right? So we got internal route, the 55.0 network, which was this right here, right? Let's take a look at it. He's saying next hop is quad 0. Legacy metric, there's the delay, which is basically the infinite metric, as you can see right here on the slides. That number right there. Once this number is set, that means this route is unreachable for EIGRP. So we set the maximum metric to an EIGRP route. That's this number right here. Next thing, okay, so let's go ahead and do the same thing with OSPF. We have two OSPF areas right here, right? We got area 0 and area 1. We're going to do the same thing, but we're going to shut down the loopback on router 7. And we're going to capture packets. We're going to capture packets right here and see what happens when we shut it down. What happens? How does OSPF poison routes? OSPF poison routes by sending an LSA, which is link state advertisement, the link state advertisement age metric of 3,600 seconds. Let's go ahead and watch that happen. Let's go ahead and start a capture right here. So here's what we're going to do. We're going to shut down the loopback interface that's located here on router 7. Router 9 knows about it. And then we're going to see what happens when he poisons the route to let him know, hey, the 10 network is no longer available. Obviously, he's going to take it off his routing table. Let's go ahead and take a look at router 9. Let's console in router 9 and take a look at his routing table. He should have this network, that network, and this network, even though he's in 2 different areas right here, right? Even though he's got 2 different areas to deal with, actually. So let's go into router 9. Take a look at his routing table. Show IP route. Does he know about the 10.0 network? Yes, he do. It's a intra-area route. It's an inter-area route or inter-area route. 110, 3 hops away. 3 is the metric, right? So let's go ahead and shut down that interface or that network and see what happens. Obviously, he's going to take it off his routing table, but we want to see what happens when the route gets poisoned first. Then he's going to remove it from his routing table. So we need to, who has that network? That network is off of router 7. It's right here. Let's go ahead and console in router 7. So we know how router 9's routing table looks like, right? All right, that's his routing table right here. He has a route to the 10.1 network. We're going to shut that network down. Let's see where it's on router 7, but I don't remember if I think it's a loopback. Yeah, it's a loopback. Let's make sure. Show IP route OSPF. No, let's just do show IP route. Show IP route, and the 10.0 network is a loopback interface, right? So we are going to go back to router. Actually, stay here. Configure. Go in global config mode. Interface loopback 0. And we are going to shut that bad boy down, and let's make sure we are capturing packets and watch it happen, right? So we're going to go to router 7. Take a look, keep a look on this side right here, right? We're going to shut this bad boy down. Shut down. And then we got a link state update right here, right? Link state advertisements are letting give them updates like when we learn a new route or a route becomes unavailable, so on and so forth. That's what LSAs do. Let's go ahead and take a look at the update OSPF, and let's take a look at the OSPF header. It is not located in there. I believe it's located in the update packet. There it is right there. Link state age 3600 seconds. He said basically router 9 says, hey, this was an LSA that's about 3600 seconds. That's too old. I'm gonna have to take this off my routing table. And remember, router 9 had it in his routing table. He had this network. Router 9 had this network in his routing table. Let's take a look at router 9's routing table now. Right? This is where it was, right? He had a route to the 10.0 network. Show IP route, and the 10.0 network is no longer available. He took it off his routing table because it was poisoned. He got a poisoned route and realized, okay, the max age of that LSA was 3600 seconds, and he removed it from his route. So that's all what we've got today. If you like this video, that's my comment. That's my I'm real anxious for y'all comments and suggestions and stuff. That's my contact information right there. That's my YouTube and that's my Twitter. You can contact me there if you have any questions, comments, or anything like that. Please go ahead and share this video. If you like it, comment, like, subscribe to the network.